Hello and welcome to Mentora IAS. I am Safir and I welcome you to this session of Current SAAR. We are covering the current affairs of the month of January 2025 and today we are going to take up the subject of geography. So in this particular session we are going to talk about three very important yet a pretty unique kind of thing that happened in the month of January 2025. Okay. So we'll be talking about Brahmaputra river, we'll be talking a little bit about the Gulf of Mexico, and then lastly we'll be talking about one of the most important canals for international trade, that is the Panama Canal. ठीक है. So इस सेशन में हम बहुत सारी ऐसी चीज़ों को डिस्कस करेंगे जो probably आपको ऐसा लगता हो कि आज तक आपको पता है, but subsequently आज उसको एक नए लेवल से देखो, so that प्रीलिम्स के एग्जामिनेशन में कोई बाउंसर क्वेश्चन आए तो आप उस क्वेश्चन को आराम से फेस कर सको और उस पर भी अपनी हुक शॉट लगा के स्ट्राइक कर सको. So we are going to discuss some of the most important aspects of these things with respect to preliminary examination, and this is basically to prepare you for any kind of unwanted or you can say surprising questions that may come up in prelims with respect to such topics. So let us begin, and before I begin I would want you to take note of these social media handles that we have. So we are active on Instagram, we are active on Facebook, we are active on YouTube, and we are active on Telegram as well, of which I would really want you to join the Telegram channel for two reasons. One, you are going to get a lot of UPSC centric content there, and second, every single video that comes on current affairs on this particular channel has got a detailed handout with it. Okay, that detailed handout and including the current SAAR program where we have all the questions covered, in questions की explanation भी उस particular handout में है. So you will find those handouts with the explanations to all the questions that we cover in this particular series as well. Okay, so I would really want you to join that particular channel and take the maximum benefit for augmenting your preparation. Okay, so now let us begin with the very first topic that we have at hand, and that is the beginning of the construction of the world's largest hydropower project. Okay, so this particular you can say news was there in the month of January, because towards the end of 2024, on 25th of December 2024, the Chinese government actually approved the construction of the world's largest hydropower project on the Yarlung Zangpo, or what we know as Brahmaputra in India. So in the context of that, we are going to read about this particular river, its course, and what exactly this dam is all about. And at the same time, we will be discussing a little bit about what exactly is hydropower. Okay? So that is what we are going to discuss. So this is first of all the Yarlung Zangpo. Okay, this is the Yarlung Zangpo, and subsequently this particular river in India. Okay, in India, when it enters the state of Assam, it is called as the Brahmaputra river. Okay, and subsequently when it is going to Bangladesh, it will have a different name that we'll be seeing. Okay, so let us talk about this particular river, and here is the Great Bend. So let us also discuss about what exactly is the Great Bend and why exactly are we talking about this. Okay, so everything will be covered in this session. Pay close attention, and I would want to simplify this for you so that you get never confused with such questions. Okay, so देखो news में क्या था. News में basically it is the Chinese government's approval to start the construction of the world's largest hydropower project on the Yarlung Zangpo river. Okay, now this particular dam will be called the Medoc Dam. Okay, it will be called the Medoc Dam, and it will be constructed at the Great Bend of the Yarlung Zangpo. Okay, so this particular project had its official groundbreaking ceremony and the beginning of the construction on July 19th, 2025. Okay, the Chinese premier were actually present in this particular occasion, and after this the construction has now begun in China. Okay, this particular dam is located in the Tibet Autonomous Region of China. Okay, so that is basically where we are going to find this particular project, and it basically will be a collection of 5 dams that will be constructed, okay, one after the other, so as to harness the, you can say, hydropower from each of these stations with respect to the flow of the river water. Okay, so we will be discussing about what exactly are cascade dams as well, don't worry about it. Okay, and what is expected out of this entire project is that once it is completed, it will generate about 60,000 megawatt of power for China. It will help it augment its electricity supply. It will also help it meet its carbon neutrality goals, and subsequently this particular power plant project will be the largest in the world. Okay, So it will be the largest hydropower project in the world. So the current largest hydropower project is also in China, but on a different river. Okay, and this will be basically the next one that will be there. So if you know the current largest hydropower project in the world, please comment in the comment box so that we can be sure that your knowledge is up to the date. Okay, so let us talk about first of all the Great Bend. Okay, so this bluish, you can say, streak that you're seeing is actually the course of the river Yarlung Zangpo, which in India is called Brahmaputra. Okay, so this is basically what is called as the course of Yarlung Zangpo. That is how this particular river is known in this particular region. Okay, and then after moving through an entire U-turn, it enters into India in Jelling or Gelling. Okay, this is basically the state of Arunachal Pradesh. Okay, and now when it goes into India, it is going to be known as Brahmaputra. Okay, but there is a you can say a difference. When it actually is in Arunachal Pradesh, it is known by a different name. If you know that name, please comment. If not, stay tuned. Okay, so Arunachal Pradesh is basically the one which is the first state to receive this particular river at Gelling or Jelling. Okay, so in this particular, you can say, U-turn, there is a very important mountain which is actually called Namcha Barwa. Okay, so this is basically the mountain around which we basically see this river taking a U-turn. Okay, a similar course is what you see with respect to the river Indus. Okay, when it is actually flowing from India to Pakistan. At that particular point, the name of the mountain is Nanga Parvat. Okay, so I am telling you that one because I don't want to load you with a lot of information. But the point is, what are we seeing? One river at the you can say at the tip of you can say almost northwest of India, and one river to the northeast of India. Both of them take a U-turn. So this is something which is actually called a syntaxial bend. Okay, this is something which is called as a syntaxial bend. Okay, so what basically happens in this particular place is that the continuation of the Himalayan chain actually takes a sharp U-turn. It takes a sharp turn in its direction of orientation, and that is basically how the rivers also take this particular U-turn. Okay, so that is the first thing. We need to know what exactly is the Great Bend. Now the province in which this particular dam is being constructed is actually called as the Ningchi province. Okay, that is basically the name of this entire province, and this is the Medog region where one of the dams will be constructed. Now the whole point being that we are talking about cascade of dams. Okay, so in this particular analysis we have two different aspects to look at. One is basically what exactly is hydroelectricity, how exactly is it generated, and what exactly are cascade dams. The second one is the geography with respect to the course of this particular river. Okay, so let us first of all understand what exactly are the objectives of the project that China seeks to achieve. So with respect to this particular project, China actually wants to achieve, or you can say further, its goal of carbon neutrality. So when you talk about carbon neutrality, okay, so carbon neutrality is basically the carbon emissions generated that would be equal to the carbon absorbed from the atmosphere. Okay, so this is something which is going to make any particular country carbon neutral. So whatever are the emissions that you are going to make, how exactly are you going to make the emissions? By burning of fossil fuels, by industrial processes, by steel making, okay, by exploration of oil rigs. So in these particular regard, what happens is that whatever sources are actually going to add carbon dioxide into the atmosphere, those are the ones which will be called as carbon emissions, which are anthropogenic in nature. Now carbon emissions can also be happening through natural features like volcanism. So volcanism wali cheez ko we are not going to consider. What we are going to consider is the ones that have been done by the humans deliberately. Okay? So carbon emissions that have been generated, they should be equal to the carbon that has been absorbed from the atmosphere through the initiatives or the projects of the government. Okay, if you seek to achieve this, you are supposed to be called a carbon neutral country, and eventually we would want to transition from carbon based economy to decarbonizing the economy. So decarbonizing the economy basically means we do not want to rely upon carbon as a source of energy. We do not want it to use as a source of fuel as long as it is not required. Okay, now it is something which is impossible to say that we can completely rule out carbon based or fossil fuel based you can say energy generation. It is impossible because in certain regions you will not be having any other feasible source of energy. So that is why we want to minimize that. Okay, only to exceptional circumstances, but the major demand should be met by such resources which are not polluting. Okay, so that is the overall objective of sustainable development in order to curb the climate change. So now China basically has set itself a carbon neutrality achievement target of 2060, and this target for India has been set for 2070. Okay, so for India it has been set for 2070. Okay, so China and India, both of them are developing countries and they rely heavily on fossil fuels in order to generate energy for running their economy and at the same time for the transportation sector of the country. Okay, so that is why they are heavily dependent upon carbon, but even then they have a lesser amount of carbon consumption per capita as that of the USA. Okay, now the second thing, energy security. That basically means that in any part of the entire country there should be no deficiency in power supply. So power supply should be reliable and it should always be consistent. It can never be the case that the power supply is actually in any way disrupted. So energy security, you would want to ensure that all the places of the country are always having electricity. Okay, so for energy security, this is an additional amount of power that will be generated by the hydropower plant. The third one, regional development of Tibet. Now with respect to the history of Tibet, Tibet basically wanted to be an autonomous region and subsequently having a separate identity from that of the Chinese. Now with respect to this, there was a rebellion in the Tibetan region in 1959 which was crushed by force using the Chinese, and since then Tibet has been granted some amount of autonomy, but at the same time they have always been governed by the Chinese appointed governors. So that is why in this particular region they would want to ensure that the people, the youth, are actually meaningfully engaged. So with respect to this particular project, it will be generating employment. It will also be furthering the concept of innovation in the region of Tibet. So for the regional development and infrastructure of Tibet, this is an important project with respect to China. And finally, the power supply and the energy mix will have a greater share of hydroelectric power supply. Okay, so these are basically the objectives that China seeks to achieve. So this is basically what is the Yarlung Zangpo's Great Bend. This is the Great Bend. Okay, now look at the grandeur that this particular mountain that you are seeing. This mountain is what is Namcha Barwa. Okay, this is Namcha Barwa. And what you will be shocked to know, okay, is that this part is Tibet and this part is India. Okay, so because this particular you can say photo has been taken from a great amount of distance, it may seem that they are very close, but this particular thing is almost 30 kilometers away. Okay, it is 30 kilometers away from the Indian border. So the Indian border actually starts from the end of this particular photo. Okay, now what exactly is the objective is that they would want, the Chinese would want to create multiple dams in this region in order to generate the you can say the hydroelectricity in this particular region. Okay, so this is the Great Bend. Now how exactly does this concern India? So first of all, it concerns because there will be damming of water. Okay, so when you are damming the water, so what happens in this particular case is that this is going to result in two very important downfalls, and that will be, first of all, that it will be regulating the water during dry seasons, because what you are doing is that you are damming the water. Okay, so what exactly is damming? Damming basically means that you want to deliberately stop the natural flow of water. Okay, so how do you do that? You basically do it using the construction of a reservoir. So you basically divert some amount of water into the reservoir and let the reservoir fill up with water. So what is happening? The natural volume of water which is flowing in the river is reduced. Now what is going to happen during the dry season or during the time of summers? The evaporation will also be higher. Because of the evaporation, the natural flow of the river naturally is going to go down. And at the same time, now because of the diversion of the water to this dam, what is going to happen? That there will be further reduction in the amount of water. And subsequently, in this particular regard, what are we going to see? That the riparian states like India and Bangladesh, okay, the downstream states of this particular river, they basically are going to, you can say, face reduced flow of water. Okay, so that will lead to water scarcity. So this is something which may lead to water scarcity. That's the first thing that we have to understand. Okay, and this is what India believes, that in the future there is a significant amount of doubt or suspicion that this is something which will lead to weaponization of the dam in the future. Okay, weaponization of dam in the future, because what we basically believe is that when this particular water is going to be regulated by China on this particular front, so at that particular point it may suddenly release more amount of water as well, and that can flood the downstream region, that is basically in India and subsequently then in Bangladesh, and this could be used to pressure India to give certain concessions to China or make its term agreeable for India. Okay, so that could be used as a coercive measure as well. That is one of the greatest concern that India has with respect to damming of the water. The second thing is basically that it will stop mineral rich sediments. Okay, so it will stop mineral rich sediments. Now these sediments are going to be very, very important. Okay, this is something which is very, very important for the fertility of land downstreams. So this is going to be stopped. Okay, so this is going to significantly impact the food security of the region, and at the same time it will also reduce the fertility of this particular region. The third thing is basically going to be the irreversible ecological damage that will be done at this particular location. So irreversible ecological damage. So these are basically the ones which actually are very, very important for consideration with respect to India and its interest. Now to add to this entire point, there is another very, very important issue that must be addressed. That is basically that this region is tectonically active. So when it is tectonically active, so what may happen is that this may result, because of the tectonic activities, there could be a situation that we have a strong earthquake and that may cause dam failure. And when the dam is going to fail, it is going to release an enormous amount of water downstream into the river, and this will be devastating for the entire northeastern region of India. And subsequently, that is a primary concern which is there with respect to the geologists of India as well as that of Tibet region as well. So these are basically the concerns of India with respect to you can say this particular project, and that is why India has very clearly said that China has to actually always send the data in a transparent matter or in a transparent manner with respect to Brahmaputra in order for this entire thing, okay, to work in a fruitful manner. So India cannot actually stop China from doing this because it is its sovereign territory. But the point is that India is saying that your hydrological data related to the flow of the water in the river must be shared with India on a timely basis and in a transparent manner, so that India can prepare its mitigation in case of any emergency. Okay, so that is basically the concern. Now when you talk about hydropower generation, okay, so let us talk about hydropower. So when you talk about hydropower, so this is basically the utilization of the energy, okay, utilization of the energy of flowing water, energy of flowing water, okay. And what would you want to do from this? You would want to generate electricity, okay. Now when you talk about the utilization of energy of flowing water, this energy is basically the kinetic energy, okay. So kinetic energy is basically the energy that is possessed by any substance or anything that is in motion. So just like my hand is right now in motion, I am myself in motion, so I have that kinetic energy within me. Okay, so only that, because of that I am able to move. But how exactly this kinetic energy gets created? This kinetic energy gets created due to a difference in the height of water at two separate regions or two separate points. So how do you imagine this? Imagine that you basically have a you can say tumbler of water upstairs, that is basically on your roof. Okay, now what happens is that you have kept this water at the wall of your roof. Now accidentally you push this water. Okay, so you basically were doing something and you accidentally happen to push this tumbler of water. What exactly happens? The tumbler tips and the water falls naturally to the ground. So why exactly is the water falling to the ground? Because of gravity. But at the same time the water has the motion created on its own. Why? Because you are at the level of the roof and the ground is at a lower level. So because of the difference in the height in between the two zones, you basically see that the water naturally flows. This is how the water flows from the mountains all the way to the oceans. Okay, why? Because there is something called a slope. There is something which is called as a gradient which is present, and as long as a gradient is present, the water will naturally flow. So gradient is actually the difference in altitude or difference in height at two different places. So this gradient is something which is utilized for generation of electricity through water. Now this is basically one of the ways of renewable energy generation. So this is actually considered a part of the renewable energy. Although it has its downsides as well, that it causes submergence of a large portion of land, it causes displacement of the flora and fauna and the people, and at the same time a lot of siltation happens in the dam. But the point is that this is one of the cleanest way to generate electricity without a lot of initial investment. Okay, with respect to the you can say the harnessing of electricity with respect to solar power plants, atomic power plants, what is going to happen is that you need brilliant and big amount of money. Okay, here the initial cost is relatively low. That is why, especially in the mountainous regions, this is one of the most important ways of generating electricity. Now how does this happen? Okay, so first of all what we do is that from a river, let us say this is the river that is flowing, we divert a part of this water into something called as a reservoir or a dam. Okay, so dam is nothing but a high wall that has been created across the breadth. So you basically want to stop the flow of water and you would want to discharge it at your own will. So it is technically a kind of tank. Okay, so water is flowing into it. So when the water flows into it, what happens is that the level of the water keeps on rising in the dam. Okay, now what happens is that this level of water which has risen in the dam, this is something which is going to be responsible for the generation of electricity. So now what you do is that from this reservoir we actually make a channel. Okay, we make a channel which is slanting in nature. That is something which is called as the penstock. So penstock is nothing but an inlet to the you can say the hydropower plant. So what is going to happen, this slant that has been created, now this is something which will cause the water from this reservoir to naturally flow. So when it is going to naturally flow, what happens is that this particular water is hitting a particular object called a turbine. So turbine, you can imagine, is a kind of fan which rotates because of the pushing of water. Okay, so the faster the water is going to push it, the faster the turbine is going to rotate. And the faster the turbine is going to rotate, it is coupled with something called as an electric generator. So this is the object or device that is going to generate electricity because of the rotational movement of the turbine. Now subsequently what is going to happen, once the water hits the turbine, then eventually it is then going out into the river. Okay, it is then discharged into the river. So you are not trying to hold this water, but the point is that this particular water is important with respect to you can say the initial level. Now what is the maximum height till which you can see a drop? So the maximum height till which you can see a drop in the level of the dam is basically these two heights. Okay, so till this particular height, Okay, you are going to see the difference that has been there between the two. So the water is basically here. Okay, this is H1, and right now the water is here, H2. So the difference between these two, okay, so the water naturally flows like this under the influence of gravity, continuously hits this turbine and keeps on rotating the turbine. The turbine is going to generate electricity. Then subsequently this water is going to be discharged into the river. Okay, this is how a power plant which is generating hydroelectricity works. Now what happens is that when you talk about a cascade dam, so in a cascade dam what happens is that you basically have only one of the dam that is receiving water from the river. Now from the river the water is getting deposited into the reservoir and subsequently it is being discharged into this particular turbine for generation of electricity. Now once the water is getting released, so instead of going to the river, it actually gets into the next dam. Okay, so imagine that you basically have a layer, or you can say stair like structure. So when you talk about a cascade dam, so cascade dam is basically a kind of structure like this. Okay, so what is going to happen, this particular point is basically the one which is going to receive water. It will receive water from river. Okay, so it receives the water from the river. Now subsequently what happens is that in this particular regard, once the water is received from the river and it generates electricity in the hydropower plant, now the water will be discharged into the next dam. So this is dam 1, dam 2, dam 3, dam 4, and subsequently we have dam 5. So the exit of this dam will be the inlet of the next dam. The exit of this will be the inlet of this. And what exactly are you seeing? That the dam has an overall slope which is downward. Okay, so in this particular regard what is happening, because of the adverse slope or because of the change in the slope, the water continuously keeps on flowing, and eventually at the last dam then the water is going to be discharged into the river. Okay, so this is the cascade dam plan which is there with respect to the Chinese project. Okay, and in this particular manner the Chinese are also counteracting the claim that we are not going to divert an enormous quantity of water, we are only going to divert that water which is required for the first dam, and then subsequently all the other dams are going to be fed by it. Okay, so that is the concept of cascade dam. I hope you could understand this and you would not need anything more than this for your prelims examination. Okay, now why do you want to build this thing at the Great Bend? So what happens is that in the Great Bend, at the Great Bend region, what is the distance is basically the distance between point A and point B. Okay, so let us say there are 2 points, that is point A and point B. Okay, the horizontal distance between these 2 points, the horizontal distance between these 2 points is basically 50 kilometers. Okay, now what is happening is that in these 50 kilometers there is a slope of 2000 meters. So when the river is flowing from point A to point B over the Great Bend, the water actually flows down an altitude or a distance of 2000 meters when it is actually reaching the other end. Okay, so technically when you look at the 3D imagination of the you can say the Great Bend, it is something like this. Okay, so this point and this point may have a linear distance of 50 kilometers, but altitudinally this is basically 2000 meters below the first point. Okay, so throughout the journey the river is actually flowing in this helical kind of fashion. So China wants to exploit this drop in the Great Bend. Okay, so that is why it has chosen this particular Great Bend as the site for this particular project. Okay, the currently largest operating power project is also in China. This is the largest dam that is there in the world, and this is basically called the Three Gorges Dam. Okay, this is called the Three Gorges Dam. So everyone who has actually commented this particular thing, kudos, you could know this. Now the next task for you is to comment on which river is this particular dam. Okay, so this is basically the question for you. So this is the Three Gorges Dam when you see to it. Okay, and if you have a panoramic view, this is how it looks like. So this is where the water is getting stored, and now when the water is getting discharged, this is basically where you have all the turbines. Okay, so the water falls with a great force, the turbines run, and then the water gets discharged from this part, and then subsequently it is going ahead. So this is basically the concept of Three Gorges Dam. Okay, now let us talk about Tibetan Plateau. Okay, now Tibetan Plateau is basically a high plateau or the highest plateau in the world with an altitude of about 2500 meters. Okay, because of being the highest plateau in the world, it is also called the roof of the world, and if you have to be very specific, that is basically associated with the place named Pamir, which is actually found in this particular plateau. Now the Tibetan Plateau has been formed as a result of the collision between the Indian and the Eurasian plate during the time of the formation of the Himalayas. So basically what happened was that the Indian plate with respect to the Eurasian plate is smaller. So when the Indian plate came and hit the Eurasian plate, so there was a part of the Eurasian plate which experienced folding. But apart from the folding, there was another part that actually, you can say, it elevated as a flat tabletop portion. That is something which became the Tibetan Plateau. So Tibetan Plateau basically lies north of the Himalayan ranges. So all the folding resulted in the formation of Himalayas, and beyond this, in the region of the Eurasian plate, there was a, you can say, a knuckle kind of, you can say, upliftment that was done, and that is something which is called as the Tibetan Plateau. Okay, now this particular Tibetan Plateau from long before the formation of Himalayas has been the source of a lot of different rivers. Okay, this is basically a source of a lot of different rivers. Now what happened was that Himalayas are a relatively recent kind of formation with respect to the geological time. So what has happened, that because of this we find that the Tibetan Plateau has got rivers that were flowing that are older than Himalayas, and one such river is Brahmaputra or the Yarlung Tsangpo. Okay, so let us now understand the formation of the Tibetan Plateau, that I told you that the Indian plate is in compression with the Eurasian plate. Because of this, what has happened, that there is a region that is having the folding. Because of the folding, we have the formation of the Himalayas, but beyond this folding, we have a more elevated kind of portion that has been coming up because of the continuous, you can say, compression. So here we see that the Indian plate is subducting down, and subsequently the Eurasian plate is rising up. Okay, so Indian plate is coming down, the Eurasian plate is rising up, and that is basically what has resulted in the Tibetan Plateau. Okay, so when you talk about this, Tibetan Plateau has been the source of many of the major rivers of Asia. Okay, so we can count these rivers. We have Indus. Okay, Indus that flows from China towards India, then towards Pakistan, subsequently into the you can say the Arabian Sea. Then we have Satluj. Okay, Satluj is also one of the rivers that starts from Tibet. Okay, now we have the Yarlung Tsangpo, which eventually becomes Brahmaputra, and it drains its water in Bay of Bengal. Then at the same time, there is another river called Irrawaddy. Now Irrawaddy is basically one of the river that drains its water in the Andaman Sea. Then we have Salween, another river that drains its water in the Andaman Sea. We have Mekong. So when we talk about Mekong, Mekong is basically the one which drains its water in the South China Sea. Then we have Yangtze and Yellow. Okay, some of the longest rivers in the in Asia, and they basically drain their water in East China Sea. Okay, so you can see that a lot of different types of rivers actually originate from the Tibetan Plateau just because of this. And the Himalayas basically being of a recent formation, all these rivers are called antecedent. These rivers are older than Himalayas. They already had their paths carved out. Now what happened was that because of the folding of the Himalayas, what happened was that these rivers started cutting down even more rapidly because of the slope. And that is the reason why we have the canyon that is created at Yarlung Tsangpo. So the Great Bend is the deepest canyon in the world. Okay, so based upon this information, let us try to solve this particular question. You can pause your video and you can try answering this and comment in the comment box. Okay, so the question is that we have pairs of river and the water body where it flows. So consider the following: the river and the water body: Yangtze, South China Sea; Irrawaddy, Andaman Sea; Brahmaputra, Bay of Bengal; Mekong, East China Sea. And we have to tell how many of the above pairs is or are correctly matched. So if you have seen the previous you can say slide very carefully, you would have found that Brahmaputra definitely flows into the Bay of Bengal. We have seen Irrawaddy flows into the Andaman Sea. But when you talk about Yangtze, Yangtze basically goes to East China Sea. Okay, and Mekong flows into South China Sea. So these pairs are wrong. So how many of them are correct? Only 2. Now mind you that a similar question has already been asked in 2023 with respect to river Ganga. Okay, and before that in 2020 and in the year of 2020 there was basically a river based upon the rivers of Africa and Europe, about which water body are they flowing into. Okay, so these are very common questions in the civil services examination. Now talking about Brahmaputra. Okay, so Brahmaputra basically rises from the Kailash ranges of Tibet. Okay, now if you want to know about the specific glacier which it is there, so currently it is believed that it rises from the Angsi glacier. Okay, somewhere you are also going to find that there will be the name of Chem Yadung Gang. Okay, you might find this particular glacier name as well, but now it has been seen conclusively that it rises from the Angsi glacier from the Kailash ranges near Mansarovar Lake. Okay, and from that point onwards it starts flowing in an eastward direction through the region of Tibet. Okay, now when it is flowing through the region of Tibet, it is basically called Yarlung Zangpo or the purifier. Okay, so in this particular region it does not receive the waters of a lot of different rivers. Okay, so in this particular region, this region is relatively drier, and subsequently this particular river is not as you can say massive as it becomes in India. Now what happens is that once it flows through the region of Tibet, it takes a U-turn at Namcha Barwa. Okay, from there when it takes a U-turn, it moves into India via Arunachal Pradesh through Geling. Okay, now the point is at this particular location is the Great Bend. Okay, so this is where we have the Great Bend, and it is known as the deepest canyon in the world. Okay, it is the deepest canyon in the world. Now subsequently what do we understand from this? That in this particular region the river falls through a very great altitude or very great height. 2000 meters over a distance of 50 kilometers is a very great fall. Okay, and why is this happening? Because earlier, before the formation of Himalayas, the river must have been flowing in a certain course. Okay, now because of the coming up of the Himalayas, now what happened was that the slope of the land changed. Because of the change in the slope of the land, the erosion of the river increased further, and when the erosion increased further, what happened was that the you can say the elevation of the Himalayas due to the compression and the cutting down by that Brahmaputra river or the Yarlung Zangpo actually resulted in this U-turn motion, forming a canyon. So canyon is basically created because of the continuous erosion by the river and continuous uplifting of the land due to tectonic forces, and that is what created this canyon called the Great Bend. And subsequently from there we basically see that it enters into India in Arunachal Pradesh as Siang. It enters into India as Siang. Then from that particular point, when it enters into you can say India and flows towards the mainland towards Assam, so at that particular point we find that it is met with Dibang and Lohit. Okay, these are the first tributaries which are major tributaries to meet Siang, which is the name of Yarlung Zangpo in Arunachal Pradesh. And then after this particular confluence near the town of Sadia, okay, it basically is called the Brahmaputra. So Brahmaputra is actually born after the confluence of Siang, Dibang and Lohit. Okay, from now onwards it is going to be called the Brahmaputra. Okay, now this Brahmaputra, when it flows through the you can say region of Arunachal Pradesh and you can say Assam, it is joined by numerous tributaries. Okay, they join it from both left side as well as right side. Okay, some of the major tributaries that join it are basically the first one being Subansiri. Okay, Subansiri is basically also called the you can say this particular river is also called the Gold River because it is believed that there are gold deposits at the bottom of this river. Okay, so this river also originates from the Tibet region. It flows into the Brahmaputra. Then the next major tributary that it has is Dhansari. Okay, so Dhansari, then you have Subhansari, you have Kameng, you have Kopili. Then you basically see that it enters into you can say Assam, and then it is met with Manas. Okay, so Manas is another river which basically is also the one based upon which we have the you can say the Manas wildlife sanctuary, Manas National Park and Wildlife Sanctuary. Then basically what happens is that it takes a U-turn, it takes a sharp 90-degree turn. This is something which happens at Dhubri. Okay, so at Dhubri it takes a 90-degree turn, and from here it basically enters into Bangladesh. So when it is entering into Bangladesh, it is met by another very fast flowing river that originates from Sikkim, that is called Tista, and from here we basically see that it enters into Bangladesh. In Bangladesh, this particular river is met by Ganga, which is known as Padma in Bangladesh, and the confluence of Brahmaputra and Padma in Bangladesh is known as you can say Meghna. Okay, and subsequently as Meghna it drains into the Bay of Bengal. Okay, so in the Bangladesh stretch, this Brahmaputra is also sometimes called as Jamuna. Okay, so that's the thing. So this is basically the course of river. Now this river brings in enormous amount of sedimentation in this particular region. It receives a lot of rainfall in this particular region and is one of the major sources of water. Subsequently, it is also known to frequently shift its course. Okay, it frequently shifts its course, and subsequently also happens is that in this particular region of Meghna, the tides, during the tidal movement of the water in the tides is so strong that it reverses the direction of the water to a certain extent, and that is why in this particular region there is a lot of estuary formation. Okay, this concept is actually called as tidal boring. So when you talk about tidal boring, it is the incoming of tidal water into the river, causing a reversal in the flow of river current. Okay, in the flow direction of river. Okay, so temporarily this basically happens, and only during high tide when the water actually gushes in. So in this particular region there is a salinization of water, and that is why you will find estuaries forming here. Okay, so this is basically the entire course of the river Brahmaputra. Okay, you will be reading about this in detail when we will be doing geography. Okay, so now talking about another question with respect to Brahmaputra river and its course. Okay, so with reference to the Brahmaputra river, consider the following. It enters India through Arunachal Pradesh. The river emerges from the foothills under the name Siang or Dihang. After receiving Dibang and Lohit tributaries, it is known as Brahmaputra. The river is called Subansiri in the upper reaches of Tibet. So pause this particular video, read these statements and try to you can say answer this particular question at the comment box. So I am going to solve this, that this particular river enters into India through Arunachal Pradesh. The place is Geling. From there it enters. That is true. Okay, the river emerges from the foothills, so that is basically the end of the Namcha Barwa in the Himalayas, and it comes into Arunachal Pradesh in the plains. Okay, so it comes out from the mountains as Siang. It is known as Siang or Dihang. True. Okay, both of them are true. Then after receiving Dibang and Lohit tributaries, it becomes Brahmaputra. True. This is also true. Okay, the river is called Subhansiri in its upper reaches in Tibet. This is wrong. Subhansiri is one of the major tributaries of this particular river. It is not known as Subhansiri. Okay, so the correct answer here would be that the first three statements, so only three of the statements here are correct. Okay, so that's the correct answer here. So this is basically some of the major tributaries of you can say Brahmaputra when it is in India. Okay, so this actually comes as Sangpo. It is called as Siang. Okay, so it is called as Siang. Then basically what is happening, it is met with Dibang and Lohit, it becomes Brahmaputra. From here it is called Brahmaputra. Then subsequently what is going to happen, now it will find major tributaries coming in. We have Subhansari, we have Dhansari, we then have Manas. okay, and then subsequently when it enters into Bangladesh we have Teesta. Okay, so these are basically the various rivers, okay, which join the Brahmaputra. Now answer this following question based upon the information that you have just gotten. Okay, which of the following represents the correct sequence of tributaries joining Brahmaputra from east to west? Lohit, Subhansari, Dhansari, Manas. Lohit, Dhansari, Subhansari, Manas. Subhansari, Lohit, Dhansari, Manas, and Lohit, Subhansari, Manas and Dhansari. So this is something which has been asked in 2023 with respect to Ganga. Okay, so when Ganga actually starts from you can say the region of Prayagraj and it moves towards Bay of Bengal. So what are the rivers that join it from west to east? That was basically the sequence. Here I am asking from east to west. Okay, so when you are entering from Arunachal Pradesh and then you are moving towards Dhubri in Assam, what are the rivers that join in that sequence? Okay, so the first river that joins it is Lohit. That is true, that the first river to join it is Lohit. So Lohit and Dibang, when they are in confluence with Siang or Dihang, that becomes Brahmaputra. After that, the next major tributary to join it is Subhansari. Okay, the next one is basically Dhansari and the last one is Manas. So the correct sequence would be option A. Okay, so remember that when you take this, you can say you join our Telegram channel and you download the handouts related to this particular subject, you are going to get a detailed explanation there as well with a map. Okay, so don't worry, but do subscribe to our Telegram channel. Okay, now moving on to the next two concepts which are relatively smaller. So the first one is the Gulf of Mexico. So the Gulf of Mexico and the next one Panama Canal have been in the news because of the similar reason. After the inauguration of the office of Donald Trump as the President of United States, the 47th President of United States, he made two very strong assertions. The first assertion that he made was to rename the Gulf of Mexico as the Gulf of America. Okay, so this was something which was also issued as an executive order in which the President of the United States has actually ordered the federal agencies of the United States to use this particular term Gulf of America instead of Gulf of Mexico. Okay, so in all the American official you can say communication with respect to the federal agencies, so federal agencies for them are the central government agencies, the ones which are under the control of the federal government. So when you talk about USA basically displays an ideal model of federation. There the separation of powers between the center and the states is watertight. Okay, so in that particular regard, the central government has the power to regulate some of the features which have been given to it by the agreement of the states. So in that particular regard, the central government agencies or the federal agencies have been asked and ordered that they should be calling the Gulf of Mexico as the Gulf of America. Okay, now based upon this, what has happened is that the agencies have updated their you can say communication and subsequently their notations about the water body. This is something which is also being followed by Google Maps. Okay, so Google Maps basically is now displaying Gulf of Mexico as Gulf of America for the American users, and for all the international users it is displaying Gulf of Mexico and in bracket Gulf of America as well. So this was something which was objected by the Mexican president with respect to an unnecessary irritant. Okay, so this was something which was brought into the notice of the United Nations Security Council that this is something which is unnecessary and against the UN Charter. Okay, so that is what the controversy is all about. So this is basically a snapshot from the Google Maps. So you can yourself see that here the Gulf of Mexico is now also mentioned as the Gulf of America. Now in its defense, Google basically says that it has a policy of regularly updating the names based upon the official records. So in the official records of USA where the company has been incorporated, the Gulf of America is now the official name of this particular water body. So hence they have also included this as the official name in the Google Maps. Okay, now when you talk about the Gulf of Mexico or for that matter the Gulf of America, the reason that was given by Donald Trump for this was that about 14% of the United States petroleum production comes from this particular water body. It is an extremely important source of national revenue for the country, and that is why this is something which should be now called the Gulf of America under his Make America Great Again or MAGA campaign. Okay, so this is basically what was the justification given. Now that is something which has been opposed by Mexico, and that is why Mexico still asserts that it will be called Gulf of Mexico, because that is the oldest name that has been used for denoting this water body. Okay, so this is basically the Gulf of Mexico on its map. This is something which is very important for us. Why? Because Gulf of Mexico is the largest gulf in the world. Okay, it is the largest gulf in the world. And then subsequently, what we also get to know is that this particular gulf was found, or this was formed after a series of tectonic activities. Okay, this was formed after tectonic activities involving the breaking up of Pangaea. So right from the time of Pangaea, the tectonic activities that have kept happening, they are the ones which are responsible for the formation of the Gulf of Mexico. Okay, so in the long distance geological history, this particular water body did not exist. Instead, this entire region was a dry land. Okay, but due to the tectonic activities, due to the breaking up of the Pangaea plate and subsequently conversion and collision of the older plates, what has happened is that the depression was created and eventually it was filled up with water. Now this particular Gulf of Mexico and / Gulf of America also that you are seeing is also very important with respect to the ocean currents and some rivers. So let us first of all understand the rivers that flow into this particular gulf. So we have Rio Grande, okay, and then we have the Mississippi. Both of them drain into the Gulf of Mexico. Very important for us to understand. This is something which can be asked. Okay, then at the same time, basically we have two very important straits, okay, which are actually present here. So it is connected to the Atlantic Ocean, okay, via the Caribbean Sea through the Straits of Florida, okay, and the Yucatan Channel. So when you talk about the Yucatan Channel, that is basically lying between the Yucatan Peninsula of Mexico. So this is Mexico, and on the other side you basically have Cuba. And the Florida Straits are basically between Cuba and the state of Florida of the United States. Now this entire body, the Gulf of Mexico or the Gulf of America, basically sees the incoming of the water from, if you remember the ocean currents, so what ocean current would be this? This is basically going to be the Cayenne current. Okay, so here the ocean current is Cayenne current, which comes in via the Yucatan Channel. Then this is something which actually takes a complete you can say movement here, and subsequently then it exits out from the from the Straits of Florida as the Florida current. Okay, it goes out as Florida current, and then once it emerges out from here and meets the North Equatorial current, once it meets the North Equatorial current, it basically becomes Gulf Stream. So Gulf Stream is basically one of the most strong currents in the world, and at the same time it is also a current that is responsible for bringing warmth to this particular side. This Gulf Stream, now after going to the Cape Hatteras of the eastern coast of North America, it will then become North Atlantic Drift. So these are all the parts of the Atlantic Ocean circulation. Okay, very closely remember this. When you talk about the Cayenne current, because it is a current which is located near the equator, you can see the latitude 20 degrees. So this is something which is going to be a warm current. So this entire region basically is going to be a warm current. Okay, that is also going to be the nature of the Florida current and subsequently the Gulf Stream as well. So what happens is that because this water body is a warm current, so this particular water body also generates a moist environment. So this is basically where you are going to experience always warm waters. So that is why in this particular region, because it is also within the tropical region, here you are going to have the initiation of tropical cyclones, and these tropical cyclones here are known as hurricanes. Okay, they are known as hurricanes. So these hurricanes are some of the most devastating hurricanes to move into the United States of America. One of the most famous is basically the Katrina. Okay, so Katrina was basically a hurricane that was there in 2005, one of the most devastating hurricanes to have hit the United States of America, originated due to the warm water of the Gulf of Mexico. So Gulf of Mexico is not just a water body that has got enormous amount of oil reserves and fisheries, it is also a very important climate regulator of the region. Okay, the warm and moist air over this particular water body is also responsible for bringing in tornadoes in the United States of America in the tornado alley. Okay, so there is something called the tornado alley, which is basically a region that has got the world's highest frequencies of tornadoes. So that basically happens because of the warm air that is present here and the cold air that comes from northern United States. So because of that, what happens is that there is a tornado alley where there is very strong convection that happens, and subsequently it brings a lot of disaster. Okay, so this is basically the Gulf of Mexico. The deepest point in the Gulf of Mexico is basically the 6B point. Okay, so this is basically the one which is this is basically the one which is called the 6B point. Okay, going with the same name, 6B. So that is basically the deepest point in this particular regard. The bottom of the ocean has got sedimentary rocks because earlier it was actually a completely dry land. So now because of the sedimentation, it has sedimentary rocks. Enormous amount of oil is present here. 14% of the United States of America finds its oil here. Okay, so this is the question that can be asked from this particular you can say topic. Which of the following is the world's largest gulf? So the correct answer of this would be Gulf of Mexico. Another question that could be asked is which of the rivers actually drain their waters into the Gulf of Mexico? So you have just seen Rio Grande and Mississippi. There could be other rivers as well whose name could be given, and subsequently you will have to eliminate them. Okay, so this is basically about the Gulf of Mexico. Now let's move towards the Panama Canal. So what exactly has been in the news? So this was the second leg of the controversy that was created. So when we talk about the Panama Canal, so the President of United States, again at the same time when he was asserting that Gulf of Mexico be renamed as Gulf of America, he also called for retaking the Panama Canal's control from the Panama government to the USA. Okay, he again said this, and at the same time he asserted that the American ships and the US Navy which is transiting or which uses this particular canal to transit from Pacific Ocean to Atlantic Ocean and vice versa are charged exorbitantly high you can say rates for this particular transit. Okay, and at the same time he also alleged that it is right now being operated by China because one of the companies which is incorporated here that controls the ports belongs to Hong Kong. So the Hong Kong based company has got two of its subsidiaries at Panama are basically the ones which operates two of the ports, and that is why it is basically the claim of the President of USA that this is something which is operated by China, and hence the Panama government is not acting neutrally so that they can let the access of this entire you can say canal to all the countries. So that is why he said it is well within the rights of the US to take back this entire canal. Okay. So that is basically what is the Panama Canal. So first of all, the Isthmus of Panama. What exactly is an isthmus? Isthmus is a narrow strip of land. Okay, it's a narrow strip of land that connects two bigger land masses. Okay, that's actually the isthmus. Then at the same time, this is also the one which is going to separate two different water bodies as well. Okay, and when we talk about Panama, so this is basically the link between North America and South America. So on the North American side, we basically have got Costa Rica, and on the South American side, we have got Colombia. Okay, so this entire region historically was under the control of Colombia. Then eventually it slipped its you can say control at least in the region of Panama Canal to France, and then subsequently to the USA, ultimately to be given back to Panama in 1999. Okay, so when we talk about Panama, the capital of Panama is basically Panama City. That is basically the capital city of Panama. It's always healthy that you remember such things. Okay, and then subsequently what we see is that on the you can say in this particular regard, we see towards the south is Pacific Ocean and towards the north would be the Atlantic Ocean. But when you see it on the world map, this is basically the west side, that is the Pacific Ocean, and on the east side we will be having Atlantic Ocean, a part of which is the Caribbean Sea. Okay, so this is basically the concept of Panama and the Isthmus of Panama. Okay, now this was basically a very famous route for illegally entering into the USA using something called the donkey route. Okay, and it basically involved passing through this very dense evergreen forest jungles of the Darien Gap. Okay, so this particular region is also infamous for illegal immigration into the United States. So people would go from Colombia pass all the way from here and then get into the Gulf of Mexico and then to Mexico, from Mexico to America. So in order to curb this illegal immigration, the USA is trying to completely seal off its border with you can say Mexico, and only controlled borders are actually operational as of now. Okay, so this is the question that you have. You can pause and you can just solve this question and then comment. So I am solving this question. Consider the following statements. An isthmus is a narrow body of water flowing between two major land masses. The Isthmus of Panama is bordered by Ecuador and Colombia. Okay, so isthmus is a narrow body of water flowing between two major land masses. This is something which is wrong. Isthmus is basically a body of land that separates two land masses, or that connects two land masses and separates two water bodies. This is wrong. Isthmus of Panama is bordered by Ecuador and Colombia. Wrong. We have Costa Rica on the other side. Okay, so the correct answer here would be option D, neither one nor two. Okay, so this is basically how you figure out what kind of question can be asked with respect to civil services in this particular topic. Now talking about what exactly is Panama Canal. So Panama Canal is an artificial, it's an artificial waterway. Okay, meaning that this was something which was created by the humans, and it is one of the most difficult and one of the grandest engineering projects ever undertaken in modern history. So it's a artificial waterway that connects Pacific Ocean, okay, to Atlantic Ocean. Okay, so this is basically the scenario, that in order to connect the Pacific Ocean to Atlantic Ocean, this artificial you can say water body was created at the narrowest point of the entire isthmus that was lying in Panama. Okay, so this basically means that from the Atlantic Ocean you actually are going to come into something called the Gatun Lake. Okay, so this particular lake is an artificial lake. Okay, so this Gatun Lake is an artificial lake. Okay, this has been created by diverting the flow of Chagres River. Okay, so Chagres River is basically the one whose water is being used to fill up this particular lake apart from another lake, and then this lake is basically the one which is used as a transit passage in order to move towards the Pacific Ocean and vice versa. So this entire journey actually takes about 11 hours per ship. Okay, but the point is that this is something which saves significantly large amount of you can say traveling for all the ships which actually travel from Atlantic to Pacific or Pacific to Atlantic. The alternate route of this would be all the way from South America's Drake's Passage, which is a very dangerous route. Okay, because of the enormously strong winds, what happens is that this route is enormously dangerous and treacherous as well. So this is basically Cape Horn, which would have been the alternate route, and it would have added about 11 days of additional travel just to cross from you can say Pacific to Atlantic. Now 11 days versus 11 hours, there is no comparison. So that is why this was basically made as an engineering marvel of the day. Okay, now when we talk about the Panama Canal, so it basically works on certain locks. So there are 3 locks here. Okay, so these 3 locks are basically the ones which are a mechanism to raise the water level up in order to make the ships float. Okay, so they are like stops. So what happens is that when they actually stop, so at that particular time the water actually flows in and the water is prevented from getting out. So subsequently what happens is that the entire ship is lifted because of the water, and then subsequently the ship is then transported into the Gatun. Okay, this Gatun Lake. Now this is where you see that this particular lake is about 200 meters above the sea level. So you basically have to raise that amount of water, amount of ship, and then from this the ship actually transports itself, and then it actually reaches the Pedro Miguel locks and the Miraflores lock, both of them on the Pacific Ocean. So here basically what happens is that again you actually try to inundate this particular region so that the ship can travel, and once the ship reaches here, it goes into the Pacific Ocean. So every transit is about 11 hours. Okay, so this is basically what is the Panama Canal. Now when you talk about this entire region, so this is something which was the construction was something which was, you can say, proposed by a lot of different types of naturalists, lot of different types of explorers, but it was an extremely difficult thing to do. So this particular task was then taken up by the Europeans, that is the French. Okay, so French basically started this particular work in 1881. Okay, one of the engineers from France, okay, he basically was called Napoleon Bonaparte Wise. Okay, now this particular individual was the chief engineer of this entire project, who basically secured the concession for France from at that particular time Colombia, in order to build this canal in Panama for 99 years, and subsequently then this thing started in 1881. So at that particular time, about 90% of the workforce of this entire region was African slave laborers who were actually brought in to do this particular job. But the most tough part that the French did not expect in this particular region was that this region was having evergreen forest which were very dense. Then during the rainy time, the Chagres river was the one which was very tumultuous. So it was very difficult for them to prevent the kind of landslides that was slowing down their work to dig out the you can say channel. And the third thing, tropical diseases. They were not used to these tropical diseases, so a lot of fatalities usually happened in this particular time. So what happened was that ultimately in 1889, the French team gave up. They completely stopped this work. They went bankrupt, and about 25,000 people were lost, okay, as a result of this effort. Then what happened was that the US actually brought the entire equipment from the France and this entire rights of this particular region at a cost of 40 million, and they started this work again in 1904. So when the USA actually acquired these rights, so at that particular time they actually came up with the locks design, that instead of making a sea level kind of construction, we are going to use locks in order to reduce some amount of human effort of digging the entire channel. And subsequently, using the lock design, what happened was that this project became feasible. Okay, so subsequently in 1906, when Theodore Roosevelt he actually made his first official visit to USA to Panama. So that was basically a symbol that Panama, which declared its independence in 1903, had US backing, and that is the reason why Panama also uses official currency as the US dollar. Now the point is that in this particular time, you can say a complete focus has been on public health, on controlling tropical diseases, and at the same time to you can say make the work easier by making the lock system. And in 1913, for the very first time, the waters of Atlantic and Pacific Ocean meet after a remote detonation that was done from the White House. Okay, that was a ceremonial thing that was done, and subsequently the entire passage was connected for the very first time. And then SS Ancon was the first commercial ship to actually complete the transit of the entire canal on August 15, 1914. So this is basically the date on which we basically see the opening up of the Panama Canal, August 15. So August 15 is not just a date for us as the Independence Day, it is also the date on which the Panama Canal opened up. Okay, and then subsequently after this, it remained under the US control till 1977. So in the 1977, what happened was that there was a particular treaty that was signed between the US president and the president of Panama. That was called the Torrijos-Carter Treaty. Okay, that was called the Torrijos-Carter Treaty. So this particular treaty was actually the one which made the entire possible of this entire region of Panama Canal as a sovereign territory of Panama. Okay, on three conditions. First, that this particular Panama Canal will be managed by a government owned company. Second, Panama will act neutrally and it will allow the usage of this entire canal by all the countries. And third, that the US military may enter in case of any rebellion. Okay, so in that particular manner, in 1977, when this was signed, the final control was given to the Panaman authorities in 1999. So in that particular manner, we see that the sovereignty and the control of this canal was then handed over to the Panama government in 1999 completely. Now the alternate route through this was to completely avoid this particular stretch and instead use the long way from Cape Horn and then going into the Pacific Ocean. Now this is a treacherous passage, very strong velocity winds, great amounts of eddies, and a lot of accident prone region. So that is why, in order to prevent loss of days and at the same time also ensure safety of the crew, the Panama Canal has ensured to be one of the biggest routes in order to transit between Pacific Ocean and the Atlantic Ocean. The biggest users of this particular canal are the American ships, the Chinese, Japanese, English. Okay, some amount of you can say shipping from Chile also happens through there. Okay, so that is basically what is there with respect to the Panama Canal. Okay, so basically this is all about the Panama Canal, and you'll find some practice questions with regards to the Panama Canal in your handout. So please do not forget to download your handout. I have given you a detailed description of what exactly is Panama Canal. Please let me know if there is any doubt, and also please like, share and subscribe, spread the word, and at the same time be assured that we are going to give you the best quality and only the relevant stuff with regards to your prelims preparation, because we want you right out of this process and then becoming a good bureaucrat. So if you have any doubt, please let us know. Until then, keep revising. All the very best.